Welcome. In this video, we will be analyzing patterns with pivot tables. We will again be doing this with our bank loan case, which we introduced in the prior video, Touching Data. This video's learning objectives are that on the one hand, you get familiar with the idea of patterns, you understand why they are important and very useful for prediction, and on the other hand, we will do a practical exercise making pivot tables and charts in Excel. Now, it's very important that you understand how to detect and what these different patterns mean for our bank loan data. We already introduced the bank loan case in the last video with Touching Data. In particular, the Chief Risk Officer, he tasked us to build a predictive model. Now, the business problem is clear for the HSG Bank. It's an automated handling of applications. So if new people, prospective clients, they want a loan, should we accept or should we reject them? And the other objective is, of course, to monitor ongoing loans. What is the default probability? Our objective is to build a system that is able to learn on its own what distinguishes a good from a bad borrower, rather than just relying on subjective field judgment by professionals at the bank. As you can imagine, there are quite some factors that probably influence the default probability of a loan. Now, one person behind a desk, it's quite difficult for him to judge all these different influences from various variables, and he's very prone to make an error. That's why it's good to have a trained machine that is rather objective and systematic with its decisions. In statistics, this is known as a classification. Specifically, we want to classify applicants into good and bad risks. And how do we do that? We do it by using patterns. In this video, we will be learning all about different patterns that we can observe in our bank loan data. We can learn these patterns from our past data, which the IT department has provided us from the data warehouse. Now, for instance, we could observe that in the past, people with a low income had an overproportional high rate of default. This could give us an indication that if a loan applicant has a low income, his default risk for the future might be higher. Generally speaking, a classification is simply assigning a loan applicant into two categories. The two categories being, he's probably going to default, he's probably not going to default. Now, before we download the data, let us recap from the last video that we are interested in predicting the loan status. The loan status indicates whether or not a loan defaulted in the past. We also call this the Y variable, the label, or the target, and we coded it by assigning it two values, 1 meaning that it defaulted, and 0 that there was no default in the past with that loan. The other variables in the dataset can be used to predict the default. They are called X variables, features, or explanatory variables. Now let us access the data. Notice that here we will be using the processed version of the data. This is the version which we already cleaned for you based on our findings from the last video with the missing values and the duplicated rows. We can now simply left-click on the link. This will give us the website on which we can download the data. We can open the bank loans folder, and here we want to select the loan defaults processed Excel file. We click on the upper right corner. We can then download the file. We can then open the data by clicking on it. Note again that this is quite a large data set and it will take some time to open. And enable the editing. Making pivot tables and charts in Excel is really easy. All you need to do is click anywhere in the Excel file, any row, cell, then go on Insert on above, Then click the Pivot Chart tile. Accept the pre-selected full data and create it into a new worksheet. You then have a pivot table and a pivot chart in the newly created sheet. Let's do this together. So we click anywhere, then we click on Insert, then on the Pivot Chart. We let it select the whole data and create it into a new worksheet. Now this is our empty template of the pivot table and pivot chart, which we'll use next. Now we first want to analyze the relationship between how big was an applicant's income and whether or not they were able to pay back the loan. We will do this using the pivot table and the chart. Now let us create that pivot chart together. We simply drag and drop loan status from the right hand corner to legend series, because this is our grouping variable. Grouping variable simply means that we want to do an analysis based on different groups. In our case, the two groups are either the loan defaults or is paid back, and we want to summarize a metric such as average annual income and present it for each category separately. We then check for annual income and we drag and drop it into the y variable of the xy plot. Now we see that this is the sum of the annual income. We don't want this. We want the average by category. So the average for defaulted and non-defaulted loan applicants. We do this by left-clicking on the sum of annual income. We then go to Value Field Settings and we change it to average. On the left-hand side now you see the pivot table, which gives you the numbers from the charts and the overall average here. Now what does this pivot chart tell us? It tells us that non-defaulting loans had applicants that had an average income of around $74,000. Applicants who were not able to pay back the loan later on, they on average only had an income of $65,000. So what does this tell us? It tells us that defaulting borrowers tend to have a smaller average annual income. This is the first interesting pattern, and it could help us identify for future loans what might their probability of default be. So for two applicants, if one applicant has a higher annual income than the other applicant, or the other applicant's income is much lower, that person with the higher annual income, his risk of default tends to be smaller. Now for the HSG Bank, there could be several different interesting questions. For example, which loans default most often? Or for each loan type, what is the percentage of defaults given the historical data we obtained from the data warehouse? Or what is the average current loan amount for defaulted versus non-defaulted loans? We could also look at our historical distribution of the credit score. A further interesting question could be, what was the average credit score for defaulted versus non-defaulted loans? Try to solve the above business questions using the pivot charts. I advise you to stop the video now to try to solve these on your own. Let us begin solving the first question together. Which loans default most often? Now, it is easiest to clear the pivot chart fields by simply dragging and dropping the entries to the scroll bar. You see that small red X? That means it will be deleted. We do the same for the sigma values. Now, which loans default most often? We have which loans, that refers to the purpose of the loan. What was it used for? So we want to group it by purpose. So we look for purpose in our list, and we drag and drop it into Legend series. Our Y variable is loan status. We now have the result. We see that debt consolidation is by far the biggest default. If we hover over the bar, we see that there were 48,756 instances where a debt consolidation resulted in a default. If we sum up all these bars, we find out that 79% of all defaults were actually debt consolidation. The majority of defaulted loans' purpose was debt consolidation. But what exactly is debt consolidation? Now, it involves a person who has a lot of debt that they take out a single loan and pay off all their existing debt. Banks advertise it as being simpler because you only have one big loan instead of many, and it also could offer you the chance of getting a lower interest rate. Let us continue with the second question. The second question was, for each loan type, what is the percentage of default? Now, we already have our purpose here. There's our grouping variable. And now we just want the percentage, right? And we get the percentage by simply changing from the sum, because we don't want the sum of the individual defaults, because the default variable is coded 0, 1. So the sum of them only gives us the defaults. But now we want the average. And the average of the binary variable 0, 1 will give us what we need. So in this chart we see that from the loans given out by the HSG Bank, the business loans, they default most frequently. 45% of the business loans, they default. Taking out a loan to buy a car, only 20% of those loans actually default. So this seems to be the safest bet for the HSG Bank. All other purposes, they're around with a default percentage of around 30%. Our third question is, what is the average current loan amount for defaulted versus non-defaulted loans? So we again have the loan status in the Legend series because we want to group by that variable. So we drag and drop the purpose and delete it, and drag in the loan status. And now here, as these sigma values in that sigma values field, we drag and drop the loan status away, and we look for the current loan amount. We now want the average and not the count, so we have to change that. Now this chart tells us that for defaulted loans, the average loan amount was substantially higher at around $14,800. Non-defaulted loans, on the other hand, they only had a loan amount on average of around $13,500. This pattern tells us that bigger loans tend to be riskier. In the fourth question, we are interested in the distribution of the credit score variable in our sample. To do this, we will select the credit score variable. We first delete the other two ones, we deselect them, and look for a credit score variable. Now we are not grouping by anything, that's why we drag and drop the credit score variable to the axis categories, that is the x-axis. What we also want, we want to have the count number of the credit score. This gives us the distribution of the credit score in our sample. Now what we see is that most of our applicants had a credit score above 700. This is very clear. Only few had a credit score of below 700. But now, what does this mean? A credit score above 700, is this good? To answer this question, we need to know how the credit score is scored in the United States. We see here on this chart that the HSG Bank had its majority of clients from the good category. So only very, very few of them had a credit score which is considered to be fair. Most of them were good. Only very few were also rated as very good. Our final question relates to whether or not there is any difference in credit scores, in average credit scores, between applicants who defaulted on the loans and who didn't default. To do this, we have the credit score again here, but here we have instead of the count, we want the average. So we first change this. The x-axis we want to delete because now we want to group it by loan status. Now this chart gives us our intended result. From the chart we can see that on average, applicants who didn't default on the loan had a higher average credit score. Applicants who defaulted on the loan, they had a lower credit score. Their credit score was only 710 in comparison to over 725 for non-defaulted applicants. But we have to consider that both of these credit scores are quite good if we recall the chart that we saw before. Now let us quickly sum up the patterns we just found in the bank loan data. Now, non-defaulting applicants in comparison to defaulting applicants had a higher average annual income, a smaller current loan amount, and a higher average credit score. Furthermore, what was very interesting in the data is that of the defaulted loans, 79% had debt consolidation as their purpose. Business loans seem to be the riskiest. 45% of them default. Buy car loans, on the other hand, only 20% of them default. Now, by just looking at the data and doing some descriptive statistics, we were able to find out quite a couple of patterns. These patterns were quite interesting and showed some kind of direction. If we put this in the context of law, it could be quite like establishing guilt, whether or not that loan is going to default in the future, whether or not that applicant will be unable to pay back the loan. Now, just one pattern, we saw a couple of different ones. One pattern probably isn't enough to establish a sufficient decision at the end, whether or not we should accept or reject that applicant for giving him a loan. But we have a lot more information, we have a lot of variables, and there could be a combination of a couple of indicators, a couple of patterns that really give us a high degree of certainty that he will default in the future. Now, machine learning, it provides us with the techniques to investigate these patterns and to analyze them and to quantify the degree to which the patterns are linked to the true guilt, so that we can be certain enough that the applicant will fail in the future and will not be able to repay the loan. Algorithms were developed to find these suspicious patterns by themselves, and they start with knowing absolutely nothing, and they try to find it out themselves, and they do so in a smart way rather than just guessing. The smart way is achieved thanks to important results from mathematics and statistics. In the next video, we will be looking at a very simple classifier, and we will be applying it to a dataset of two kinds of flowers. Our covariates, or x variables, will be some features of the two different kinds of flowers. For example, like the length of the petals. And we will try to classify those two kinds of flowers just by those x variables. Thank you for watching.